In this video, we're going to use what we learned so far, including Kirchoffs laws and Ohm's law, in order to solve this circuit. As you can see, this circuit's a good step up in difficulty from the ones we've been handling previously, but still, in terms of this class, this is a pretty easy question. We will see much harder circuits in this, and I will also say that we're going to learn new techniques to solve this in a much easier fashion. But for right now, we're just sticking to the basic laws to get the hang of it. So since there's 6 things they're asking us for, I1, I2, I3, V1, V2, V3, the only way to solve for 6 variables is going to have 6 equations. So we're going to see what we can come up with. Well, one thing that I can do quickly here, if we look at this node, I can go ahead and do Kirchoff's current law. The current coming in is I1, the current leaving is I2 and I3, so there's one of my 6 equations that I can use. Next thing I can do is I can do some Kirchoff's voltage law going around our mesh loops here. So if I go around that left loop in the clockwise fashion, the first thing I see is going to be a minus 5 volts, then plus V1, then plus V2 equals 0. So we have that. Next thing that I see is if I do the right hand loop here. Now again, I'm going clockwise. So this time as I go through that 8 ohm resistor, I'm going the negative side of V2. So it's going to be minus V2, then plus V3, then minus 3 equals 0. Again, it's minus 3 because I'm going in on the minus side here. And that gives me my third equation. And then for the remaining 3 equations, we're going to use Ohm's law at each resistor. And if you look carefully, you'll see each resistor is following passive sign convention. So my Ohm's law is going to be V1 is 2I1, V2 is 8I2, and V3 is 4I3. And so at this point in time, what we're going to go ahead and do is we're going to say, okay, I have 6 equations, 6 variables. Instead of taking them and putting in this huge matrix, what I will do is I will replace my V1, V2, and V3 in these equations, and I'll end up with 3 equations and just the variables I1, I2, and I3. And so if we look at this here, we say, okay, the middle equation was V1 plus V2 equals 5. So once I replace that, it's going to be 2I1 plus 8I2 equals 5. And then on the second one here, it was, if I write this as negative V2 plus V3 equals 3, it's going to be negative 8I2 plus 4I3 equals 3. And if I move things around on this one, negative I1 plus I2 plus I3 is 0. And so there are my 3 equations and 3 variables. You can go ahead and put this in a calculator if you prefer, or we can go ahead and solve it by hand here. So we see, okay, we've got, maybe the best way to start is to multiply the third equation by 2 and add to the top equation. Then I would have 2I1 plus 8I2 is 5, and minus 2I1 plus 2I2 plus 2I3 is 0. That gives me a 10I2 plus 2I3 is 5. Make that a little neater there. And then the middle equation was a negative 8I2 plus 4I3 is 3. Maybe I'll multiply this top one by negative 2 this time and get myself negative 20I2, negative 4I3 is negative 10. When I add down negative 28, I2 is negative 7. So that means I2 is going to be positive 0.25 amps here. So there's my I2. Then I can go back and figure out my other variables here. If I plug it in, say right here, negative 8I2 is negative 2, plus 4I3 is 3, 4I3 is 5, I3 is 1.25, and then we plug both of those back in up, say in this one, negative I1 plus I2 plus I3 is 0. That's going to be I1 is 1.5. So I have I1 is 1.5 amps, I2 is 0.25 amps, I3 is 1.25 amps, and then using the Ohm's law rules, we can go ahead and find the V's here. V1 is 2 times that is 3 volts, sorry, not amps, volts here. V2 is 8I2, that's going to be 2 volts, and V3 is 4 times that is 5 volts. And you can see it's not super easy. Right, we set up all these things here. We had 6 variables, 6 equations, but we did find a slightly easier way of substituting here that we could avoid trying to do a true 6x6 matrix. So that was nice. But keep in mind that, yeah, this is what we're looking at for this type of thing for this class. Just more complicated than this.